So here's a simple experiment that'll work in a number of different contexts using a breadboard, a prototype board. You're going to need a total of 4 LEDs. You can see here I've just got 3 hooked up. I've got a fourth one just waiting for me. You're going to need one resistor. It doesn't have to be a big resistor. You can see mine that I have here is a brown, I don't know if you can see that or not, but mine is striped brown, black, black. And if you look in the blue Sunfounder kits, there is a legend for those stripes, but brown, black, black, brown is a 1, black is a 0, so brown, black, black means 1, 0, so 10, followed by no additional zeros. The third stripe is how many following zeros are going to give me my power of 10. So that is a 10 ohm resistor. The rest of this board, I have the 2 blue stripes connected by a common black wire, and that's just so that both sides will have the same power. And I've got both red stripes connected by a common red wire. I also have red and black wires hooked into the positive and negative terminals of the power supply. Finally, what I've done is I've taken from the resistor, I've taken an LED. This is a white LED, but there's in the kit there's lots of different colors, and this trick will work with all of them, although differently in some cases, and I'll leave that for you to explore. You'll see that one side or one wire of the LED is in fact longer than the other. The longer one is what should be connected to your positive terminal. So what I have here is I've got from the positive terminal, I go through the resistor, then I take the positive terminal of this and put that in place, connected to the output of that resistor, and then I go from the output or the negative terminal from this guy into the positive of this guy, negative of this guy into the positive of this guy, and then I just go connecting the negative of this guy to the negative of my power supply. And sure enough, if I now take that setup and I hook my red to the positive terminal in my battery, which is the little one, and I take my black and hook it to the negative terminal in my battery, which is the big one, sure enough, the lights come on. Now that's very expected. However, if I take this series circuit, and grade 9 in particular, you'll be looking at series circuits. If I take this series circuit and I add just one more bulb, so I'm just moving my negative output to the next one over, and I take another bulb, the long pin, the positive, connected to the short pin negative of the previous one, so all I'm doing is adding a fourth bulb in series. So you can sort of see how that's picked out. Hopefully you can zoom that in enough to see how I've wired that together. But now if I do the same thing and hook it up the same way, you can see that there is little to no glow happening there. Now, if I took those same bulbs, the same 4 bulbs, and I put them in parallel so that all of the positives are on the same strip, all of the negatives are on the same strip, with that same resistor, and then connect that to the negative side of my battery. There we are. Okay, so you can see hopefully that I've just got the all of the bulbs in the same two rows, so all of the positives and all of the negatives are connected to one another. Again, still 4 bulbs, and hook them together. Oops, looks like I've got a short. But I do get the power. Oops, I've got to get battery. That's what's wrong. We'll try this one. All of the bulbs come on. So in series, none of the bulbs come on when I have 4. All of the bulbs come on when I have 3. In parallel, all of the bulbs come on, and in fact I could keep adding. I won't here, but I could keep adding like a row of Christmas lights, and as long as all those bulbs are in parallel, they'll all light up. But if they're in series, they won't. So there's the puzzle of the day. This does apply both to grade 9 series and parallel, probably a little bit to grade 5 circuits. It also is a fit if you're looking at any quantum mechanical concepts in physics. I won't go into great depth in terms of why that is, but it's an interesting fact. I will add that, and this might be something that will help especially the grade 9s, the physics teachers can talk about why this is, but it does happen that one of these LEDs tends to drop about 2.3 volts when the power goes across it. So if the light comes on, that light energy is coming from somewhere, and the energy comes from a drop of 2.3 volts. And I'll let you guys think about why the series works different than the parallel. Enjoy the problem.